Sequel II system. So it now features an 8-fold higher multiplexing capabilities as compared to our current Sequel system. You can see that the overall smart cells actually look fairly similar to our previous version. And of course, we've made engineering adjustments to our platform on the Sequel II system to accommodate this increase in multiplex. This is the largest multiplex increase that we have done to date, both relative and, of course, absolute. You get an 8-fold increase in yield, which translates significantly to reduced project times as well as reduced project cost, all while having the equivalent performance. And so just to kind of give you a sense of where the performance is at, here's a comparison of a CCS type run. This is data just overlaying Sequel and Sequel II system results. And as you can see, the read length distributions are essentially identical. Now you simply get 8 times the output of raw data. In this particular example, it's 318 gigabases. And it also, of course, translates into 8 times the yield of highly accurate long reads. In addition, we've made improvements to the raw read accuracy so that now with the Sequel system, go forward. So now with the Sequel II system, as I showed you previously, there were 10 passes that were actually required to achieve QV30 on the Sequel box. Now on the Sequel II system, it's reduced now to 8 passes to reach the same quality of QV30, which of course then translates into higher CCS yields overall. So here's an example of an internal CCS run. This is done actually in collaboration with Hagen Tillner, who showed the first 5 rows in a talk yesterday. Since then, and this is for a single-cell isoseq experiment, since then we've actually generated additional cells. 4 more cells shown at the bottom, rows 6 through 9, have been processed, showing very good and more consistent performance. The whole table actually, of course, shows you that things are still in development and improving during this early product phase. So that you'll notice the first 3 cells had a little bit lower input. We've actually been able to adjust some of our workflow parameters, and all the subsequent cells are now showing about twice the amount of data output per smart cell. In terms of continuous long reads and how is the system performing, so compared to the Sequel system in the first column, there's now again an approximate 8-fold increase in the number of reads and the resulting yield, ranging here for various controls between 80 and 100 gigabases, all while showing very similar read lengths as to the current Sequel system. You may have seen in a press release recently from us or heard, we are in currently early access phase with the Sequel II system. We've placed the boxes at 5 selected customer sites. This is to do testing performance, both with our own controls that we've sent them as well as real-world samples. And this is using a pre-release chemistry. You'll notice on our boxes the 0.9. And of course, as we get feedback from the sites and we evaluate their runs, we'll be fine-tuning our chemistry and as well as the instrument and software for our commercial release, which we're still on target for a second quarter of this year release. The early access program, I was very excited to actually see this. This was pretty exciting for me. So it started off, in my opinion, with a bang. So Hudson Alpha was the first customer site, and just the night before Jeremy Smutz's talk at our own PAG Developers Conference, the very first Sequel II smart cell from a customer site completed. And Jeremy actually presented these results the very next morning. So this is a sorghum sample. It had 63 gigabases of data, and this was collected in 10 hours, which he's now subsequently after that has completed an assembly of this. And what you'll see in the assembly of stats here is that we have a high-quality genome assembly that was actually more complete and over an order of magnitude more contiguous than the current reference. And it was also highly accurate, this being greater than QV45 in accuracy. And so just to kind of show you some high-level overview stats of where the Sequel system is and how our early access is going and the number of runs we've done. So over about 3 to 4 weeks on average in operation at each of the sites, we've had a total of 58 smart cells that have completed running. About 20% of these were our own, again, control samples that we sent. 80% were coming from customer samples from their ongoing research. And I'm showing all of the runs here, so I'm not cherry-picking any runs. 1 smart cell failed up to this point, and with regard to performance on the long reads, we had 27 smart cells And they showed an average of 67.4 gigabases, which is about 7 times that we're currently seeing in our field over our field installs. And then for the CCS, we had 31 SMRT cells that gave an average yield of 250 gigabases, and that's about 11 times compared to the current Sequel output globally that we see. The average CCS yield was almost 17 gigabases, and the average read lengths were 62.5 kilobases. And so to summarize, the early access, we're actually very pleased. Our customers are excited about it, and we're again on track for full commercial release coming in the second quarter. And then finally, just to end, I want to again, we're continually extremely grateful to each of you, the scientific community, for continuing to apply the technology to your research. By now, there's over 5,000 peer-reviewed publications, and I can't wait to see what new discoveries will be made this year using the Sequel and the Sequel II system. So thank you for your time and attention.